All right, and we're back to another day of Algebra 1. All right, and doing some factoring. Gonna F things up today, my friends. Gonna factor it real good. All right, and so we're gonna continue with our conversation from our prior lesson when we started factoring with its greatest common factor, but now we're gonna look at expanding that and how do we factor some more complex things with quadratics. But first, that's right, we have our three warm-up questions right here, just to kind of get you thinking a little bit. And we're going to make some connections to this distribution and this combining of like terms we do when we multiply here to help us reverse that process. Because remember, once again, factoring is the opposite, all right, of distribution and multiplying. So we want to work backwards today. So, all right, I'm going to give you a little music from, and did you know there was an artist called Factor B? That's right, Factor. All right, so I'll give you a little music from Factor B while you guys work. So, or you can pause the video and give those three problems a shot. All right, so hopefully you have worked these three problems. What I'm going to do here is I'm going to jump to the work that's already completed here, just so we can quickly check your work. So based on all we've talked about with our area model so far, hopefully for your first answer here, you got x squared plus 1x minus 2. All right, for our second problem here, hopefully your answer was x squared plus 2x minus 15. And then for our third example here, hopefully you have x squared plus 9x plus 14. All right, so now here's the goal for today. What we're going to do today, all right, is that we're going to start, all right, with this problem right here. We're going to start with our quadratic here, all right? And we're going to start with this guy. And what we want to do is work backwards and figure out, okay, what did we multiply together, all right, to get this result? So instead of starting with it in factored form and moving to standard form, we're going to start in standard form and move backwards to factored form. All right, so let's look at some connections here and how that happens. So if I look, there's a connection in our area model here. And I'm going to touch upon that briefly. We're going to go back and take a little bit of notes on that first page, and then I'm going to show you a couple more examples to kind of reinforce this pattern that exists within our area model here. Now, if we look, right, if I look at x squared, notice that's always in this top left corner. So x squared, x squared, x squared, x squared. Notice our c term here, the constant term at the end, this minus 2 that we see here, look, it's in the lower right corner. This minus 15, it's in the lower right corner. This positive 14, it's in the lower right corner. So we can see from these three examples that if we are working backwards, we already know what has to be in this first box. We already know what has to be in the last box here. So the issue is, okay, how do we figure out what goes into these two middle boxes when we're undoing or going backwards? And there is a pattern to this. If I look at these first two terms, notice this is 1 and this is negative 15. So if I did 1 times negative 15, all right, so 1 times negative 15, that equals to negative 15. All right. And if I look here, notice I have a 5 and a negative 3. Well, 5 times negative 3 is also negative 15. And then when I do 5 plus negative 3, that's a positive 2 here. So there seems to be a pattern here. All right, so I'm going to move here to this first example here. Notice if I do 1 times negative 2, that is negative 2. And if I look here, 2 times negative 1 is also negative 2, but then 2 plus negative 1 is that positive 1 we have here in the middle. Interesting, right? And notice here, if I look at my last example, if I do 1 times 14, that equals to 14. And if I look here, 7 times 2 is also 14, but 7 plus 2 equals to this 9x in the middle. So there definitely looks like there's a very significant pattern, a definite significant connection between our A and C terms here and how we get these two terms in the middle. All right, so let's pause that for just a second. Let's jump back, all right, to our first set of notes here. We've already done these, all right, and just to fill in the notes here and kind of make sure we're all on the same page, let's talk about all these problems together. Now, if you look at all three of these, all right, all three of these problems represent quadratic equations, all right? So I'm going to fill that in for us right here. So those are all quadratic equations. Now, we've talked about this just to make sure our terminology is right, but when we have two things multiplied like this, we say these are in factored form. That's right. All right, let me try to maybe write that a little bit more clear for you here. All right. I think the recording software really slows down my tablet. All right, I apologize for that. So let me go back here and do that. All right, we call this factored form. All right, and then we talked about this already, that this is in standard form. All right. And in general, all right, in general, the standard form of equation is always y equals, get that equal there, ax squared plus bx plus c. All right. So when we look at what we have, we really want to understand all the parts because of what the pattern that we're going to see and develop, all right, that we started that conversation with from the three openers, all right. So plus bx. All right. And this is really the big idea here because when we think about this in standard form, all right, I'm going to pop back and kind of now put some things together with this pattern that I was talking about here. So if we think about y equals ax squared plus bx plus c. What we see is that the ax squared term always goes in this box. The c always goes here. So this number we're getting here every time is a times c. We can see that from what we have. Now, in this case, and all we're working with today is what happens when that a value is 1. So you can see a times negative 15, right? So that's a times c. A times c. All right? And now when we look at this middle value, right, that is the bx term right here, right? When we add these two terms, right, we combine line terms, that's always our bx term. But what we can see is that these two always multiply to, this multiplies to 14, that's a times c. These two multiply to negative 15, that's a times c. These two things multiply together, that's a times c. So what we're really looking for here, and the pattern that we're looking for is we have to find two things, right, that add to be that bx term. And we can see that right here, it has to add to be bx, but it also has to multiply to be a times c. All right, so once again, we're looking for two things. Oh, that's a really bad line. Really bad line. Ah, let's do backwards. All right, here we go. All right, and so we can see that once again here, right, we have to add to get that bx term, right? So we can see that we add 5 and negative 3, that gives us that bx terms, but 5 times negative 3 is also a times c. And that's really the pattern that we're looking for here. And that's how we're going to figure out how to get these two middle terms. We can see the A term goes here. We can see that the C term goes here. But we need a pattern to develop, all right, and use in order to find those two terms. Now, to help illustrate this, all right, I have three problems. These are not in your notes. This is just for you to kind of process, all right, with me right now as we move through the problems. And so what I wanted you to see was this pattern continues even when A is not 1. Now, that's going to be the focus of the next lesson, but I wanted you to see, right, that it still continues. So notice, A times C is negative 6, right? So that's negative 6. And our B term, we can see, is negative 5x, right? And if I look at these two guys right here, right? So when I add those two things, so negative 6x plus 1x is that negative 5x. And negative 6 times 1 is negative 6. So we're looking for that combination. We can see that here. Notice, 6 times 2 is 12. So we have to find two things that multiply to be 12. And notice our B term here is negative 7. That's about negative 7. Negative 7x. All right, and then notice negative 3 times negative 4 is positive 12, and negative 3x plus negative 4x is negative 7x. So that's that pattern that we want. That's really how we're going to work backwards here. All right, and then once again, you can kind of see this here. 10 times 3 is 30. Negative 5 times negative 6 is positive 30, and negative 5 times negative 6 adds to be that middle term there. All right, so that's really the idea, that we're going to use that pattern, all right, in order to find our two middle terms. All right, so let's jump into some examples. Now, remember today, we're only going to work with those terms where A is 1 today, all right? We'll get into when A is something else tomorrow, all right? But we'll always, all right, have the same pattern. It just means that we have more combinations to look at. Sorry, had to take a little drink of coffee there early this morning. All right, so now here's what we're going to do. We still have our area model. We know that the A term, all right, which is our x squared term, has to go in this box. All right. We know our C term, which is positive 7, has to go into this box. All right, so the first thing we want to do is A times C. And remember, the A value today is going to be just 1. So A times C is 7. All right. Now what we want to do is we have to get to our B term, all right, which is a positive 8x. So we have to get to positive 8x. All right. So now what we want to do is look at the factors of 7. What numbers can we multiply together to get 7 but add to be positive 8? Well, 7 only has one set of factors. It's 1 times 7, which would give us a positive 7. Or, and we have to think about this, there's two ways to get a positive number, negative 1 times negative 7, which is also positive 7. And so notice, we want to get to positive 8. So that means we're going to want this set of factors here. So notice, 1 times 7 is 7, and 1x plus 7x would be 8x. So these are the two numbers we want to go in these boxes. So we have a 1x and a 7x. Now, we're working backwards. So now here's where our GCF factoring from the prior lesson comes into effect. So here's what we want to do. We want to look at the first column, and we want to factor out our greatest common factor. So the greatest common factor between 1x squared and 7x would just be an x. Our greatest common factor here is only positive 1. So I'm going to take out a positive 1. Now I'm going to do the same thing, but now I'm going to look at my first row. And from 1x squared to 1x, my greatest common factor is 1x. Now when I look at 7x plus 7, all right, my greatest common factor is a positive 7. And notice, now here is our first factor if we're working backwards. So we know we have x plus 1. All right. And our second factor here we have is x plus 7. All right. And we have now worked backwards from standard form to factored form. All right. Okay, now, so notice we're putting everything together here. All right, now, once again, notice the way we can check this. If I were to FOIL this out, if I were to use my area model, I should get x squared plus 8x plus 7. So once again, all you have to do to check your work is just do your area model. And if your area model gives you what you started with, you know you are correct. All right, now let's move to example 2. Now, the one thing we always want to do before we start a problem, all right, is look for that greatest common factor. All right, so when I look at number 2 here, all right, okay, because it's going to make everything a little bit easier. When I look at our number 2 here, notice there's a 3 that I can factor out of all 3 things. So I'm going to do that to begin our problem. So I'm going to have 3. There we go. All right, and if I take a 3 out of that first term, I'm going to be left with x squared. If I take a 3 out of our middle term, I'm going to be left with a positive x. And if I take a 3 out of that last term, I'm going to be left with a negative 2. All right. Now, so when I write it in factored form, that constant, whatever my GCF was, in this case a 3, oh, that's not a 3. Let's try see if I can give us a 3 here. All right. It's just going to stay out front. All right, and we're just going to leave it there. Now notice now my a term is just x squared. My c term now is just negative 2. Now when I do a times c, that's negative 2. And I have to get to my b term, and now notice my b term now is plus 1x. All right, so now I have to look at how I can get to negative 2. Well, there's only 2 ways to get to negative 2. I can do 1 times negative 2, and that would give me negative 2. Or I can do negative 1 times positive 2, and that would give me negative 2 as well. Now notice I have to then get to positive 1. Well, negative 1 plus negative 2 is a negative 1. So this is the combination I would want. So negative 1 times 2 is negative 2, and the negative 1x plus 2x is 1x. So those are the factors that we want. So negative 1x and positive 2x. Now, once again, when we look at this, what we want to do is work backwards now and find our GCF in our first column here, which in this case would be just 1x. Now, when I look here, if both terms are negative, we want to take out that negative as a GCF. And then the only other thing I can take out of here is a negative 1. Now, when I look to this, my GCF here would be a 1x. And then here, notice, what's our GCF this time? All right, it's going to be that positive 2. So now here's my first factor, and I'm just going to add this on right here. So that's going to be x minus 1, and then x plus 2. Like that. All right, so moving right along here. All right, so what I'm going to do here is factor out our GCF here. So now notice our GCF here this time, all right, is going to be a positive 2. All right, so I'm going to just take that positive 2 out, and then notice that we're going to be left with x squared minus 4x, and then plus 6, or excuse me, plus 3, since we started with a plus 6. And then I'm just going to go ahead and write that constant term right here so I don't forget it later. Now that means my a term is just 1x squared. My c term is that positive 3. All right, so now when I do a times c, that's 1 times 3, that's what I have to get to. And once again, there's only 2 ways to get to a positive 3. When I multiply, I can do 1 times 3, or I can do negative 1 times negative 3. And now this is the key, because now notice I have to get to this b term, which is a negative 4x. All right, so now when I look at this, when I do 1 plus 3, I get a positive 4. But negative 1 plus negative 3 gives me to that negative 4 there. So that is the combination we want to use here. So that is, all right, the find all right, that we need to get our pattern. And then I'm just going to drop both of these guys in here. Now this one's a little trickier because anytime, all right, both of these terms are negative, I'm going to have to factor out a negative in just a moment. I'll show you with the GCF. So now if I look at my first column, my GCF is just 1x. Now, here's what I'm talking about. And like I said earlier, when they're both negative, I always factor out the negative. Now, we need this to be a positive 3, but we need this to be a negative number. So I'm going to factor out a negative 1 here instead of a positive 1, and you'll see why in just a moment. Now, when I look left to right here, my first column, my factor here is 1x. All right, now notice I need this to be a negative 3, and I have a positive 1 here. So the only way for that to happen is if I take out a negative. And then when I look at this 3 and this 3, that is my GCF like so. And now when I start looking at my area model, positive times a positive gives me positive x squared. Positive 1x times negative 1 is negative 1x, so that checks out. Negative 3 times positive 1x is negative 3x. Negative 3 times negative 1 is a positive 3, so now it all works. So you have to remember that when these two terms that give us that b term are both negatives, your factors here will always be negative as well. So I'm going to write x minus 1 here as our first factor. And then I'm going to write x minus 3 for our second factor. All right. Okay, so what I'd like you to do is pause the video, and I would like you to give example 4a go. I'll give you a little music if you want, or you can pause the video, whichever one you prefer. A little more factor B to get you going there. All right, so hopefully you have finished this problem. I'm going to go through it now and just kind of talk about what you should have. All right, so now when we look at this, notice there is no GCF, so we're good there. So we can just jump right in. Our a term goes here, so x squared. Negative 21 goes here. All right, so now when I do a times c, that is negative 21. And I have to find two terms that get me to a positive 4x. Now this one's a little bit more complicated because there's multiple ways to get to 21. So I can do, and I need negative 21. So I could do negative 1 times 21, or I could do 1 times negative 21. All right, now when I look at those, when I add those, I definitely don't get to 4x. I'm going to keep going. So my next set of factor would be negative 3 times 7, or 3 times negative 7. And then now when I add this, notice negative 3 plus 7 is a positive 4 versus 3 plus negative is negative 4. So this would be the combination that I want right here. So I want negative 3 times 7, that's definitely negative 21, and then negative 3x plus 7x, all right, is a positive 4x. I'm going to put the negative 3x in this box. I'm going to put the positive 7x here. All right. Now, when I look at my first column here, my GCF is 1x. When I look at my second column, notice they're both negative, so I'm going to take out that negative, and then my GCF would be that 3 there. Now, when I look at my first row, my GCF would be just 1x. And in my second row, all right, my GCF would be a positive 7. So my factored form would be x. Not a good x there. Let's try it again. Undo, there we go. All right, and so my factored form would be x minus 3, and then x plus 7. All right, so now we're getting very late, and this is becoming a long video, so here's what I'm going to do real quick. I just want to summarize right here, right? So to make sure that you guys are good, and then I'm going to ask you to finish the rest of these on your own. All right, so now when I look at this, we said that what we always want is that the ax squared term always goes in this box. All right, our c term always goes in this box. We know we have to add to get to that bx term here. And then what we want then is we're always going to do A times C to get this number. All right, so we need to multiply to get to A times C and add to get to that BX term. So here's what I would like you to do. Okay, there are, all right, 6 more problems left in our notes here, which I would like you to do on your own. And then to check those, you can do one of 2 things. All right, one is you could get the note sheet, open it up, all right, the full notes, and check your work that way. I think what I will do is I will do another short video going through these 6 problems if you would like more of a verbal answer and to kind of see the work and guided through that work as you check them. So great work today. All right, I will see you next time, my friends. Take care of yourselves. All right, let us know if you have any questions.